Hello guys and welcome back. So in the previous lesson we set up our initial simulation, and we also did a simple quick visualization with our volume trail. Of course currently we need the well for that. So we did that in the previous lesson, and in this lesson I basically want to go over the topic or talk about the topic of velocities and how we can make different starting velocities, dynamic velocities and directional velocities, and we will do that for now. So let me get here back the density. For example, this representation is now pretty harsh. What you can do, you can place down a volume visualize node, volume visualization, and you can pipe here the density in, and you will get a little bit of a better representation of your density field, for example. And a much better representation you will get when you just get a light, just a simple light here, and move that, and grid, for example. And now you can see you will get a much better representation of our volume. But for me, this is totally fine for that kind of way or that kind of look we want to achieve with the meshed smoke. So this is also a visualization node. Let's just color that in too. Okay, let's talk about our simulation. So what we got here now is basically our first simple simulation, and with this first simulation we can now drive that of course further. So we've got our density here, and we can drive that further. We will do that with another velocity creation, or different kind of basically velocity fields or initialized velocity directions. And I will just copy that and dive inside. And now you see we've got like a pretty static field of velocity. So if we run that, of course nothing will happen because we got static velocities. We can initialize now a vector to vector 4. And a vector to vector 4, what it basically does, it will take a position, a three-dimensional input, for example our position, and a fourth component. And a fourth component is, for example, the time. Or you can do I will just show you it. Or you can basically do it like that. So you can see we will animate our velocity direction through that parameter here. Of course we will need to change that to 3D noise, and now we can see it much better. And what we can do, we can just pipe the time in here, but that's maybe a little bit too fast, and if you want to control it, it's pretty simple. We'll just use a multiply constant, and now we can multiply the incoming value, that is currently time, by a given factor, for example 0.1, whoops, 0.1, and now of course it's much slower. So you can use that, for example, to control the speed, or you can use 5 and go pretty crazy, so that's fully up to you. but I will use a much more slower evolution, or let's use 0.25, so it's a little bit faster. And now we can pipe that in our pyro source and have a look on our top import here. So you can already see we'll get other kind of simulation here because of our velocities. Maybe we can dial it a little bit down. And what you can do, for example, you can normalize them if you want to. And let's have a look at that. And you will get pretty organic results on that. So that's basically like the dynamic thing. So you can try out that. But I will delete the normalize, so we will get a different magnitude on the vectors here. And of course, what you can do, if you maybe, for example, don't like that, I will just pipe up the frequency, so we will get a kind of distributed simulation and not a kind of directional simulation. For the directional simulation or velocities, we'll go to that topic in a second, but I will just do that here. Reset simulation. And get it back in here. And now you can see we will get a pretty good distribution in our smoke field. Of course, you can go to the visualize tab to get a little bit a better idea how your smoke will turn out. Cool, that looks good to me. Now to the directional forces or velocities. We will need again just a basic attribute WOP, and we'll just copy that name. I will copy it and call it tier for direction. And now, for example, we can use a constant of free floats vector, pipe that into v velocity, and whoops, just use x, y, the y-axis, for example, as a direction. And when we pipe that into our pyro source, we will just get an uprising simulation here, which looks pretty cool too if you mesh that. Cool. So you will get this kind of upward movement in your simulation. Another thing, of course, what you can do, play with the source. So let me just get here null source, and I will just connect them here quickly. And this is now our main source, is the sphere. But of course you can just drag another sphere out, so Alt click and just drag out spheres. Of course you can go with one sphere, make it a little bit flatter, and for example you can make like a smoke band simulation. So something like that. Of course you can go for example now for the up direction and generate like a smoke band. Of course that's maybe a little bit too thick. We can dial it in for sure. I will just make it a little bit thinner and not so long for the representation. But what we can do, we can adjust our resolution, so 0.25 for example, so 0.025. And now you will get, yeah, like this really, like this little smoke wall, so that's pretty cool too, and you can try out stuff with that. Another kind of thing, what you can do now, of course, the dynamic velocity here, and I think you will get a really cool simulation with that one. Yeah, that will turn out pretty cool. Okay. Let's simulate that a little bit. Looks pretty good to me. And now we will do a quick mesh, but we will go over some other, yeah, more in-depth meshing in the next video, of course. Just a convert VDB, so we will convert that into a VDB volume, to a VDB, and we will convert that again, convert VDB to polygon. And now you will see nothing will happen because we need to dial up our ISO value a little bit. And now, of course, this is our first